Hello, everyone. Today, we will discuss measures of dispersion, which help us understand variability in data. In chemistry, these measures are essential for analyzing experimental results, such as concentrations or reaction rates. Let's dive into the topic and explore how dispersion provides insights into data. Introduction. Measures of dispersion describe the spread or variability in a data set, while measures of central tendency like the mean or median give us an idea of a typical value. Dispersion tells us how much the data varies. In chemistry, this is particularly important for understanding consistency in experimental results. We'll focus on four key measures: range, interquartile range, variance, and standard deviation. Let's start with the simplest measure, range. The range is the difference between the maximum and minimum values in the data set. For example, consider these concentrations of a chemical solution in 5 experiments: 10, 15, 20, 25, and 30 milligram per liter. The range is calculated as the maximum value minus the minimum value, which is 30 minus 10, giving us a range of 20 milligram per liter. This shows the total variability in the data. The interquartile range, or IQR, focuses on the spread of the middle 50% of the data. It's calculated by subtracting the first quartile, Q1, from the third quartile, Q3, using the same data set, 10, 15, 20, 25, and 30 milligrams per liter. Q1 is 15 and Q3 is 25. The IQR is 25 minus 15, which equals 10 milligram per liter. The IQR is particularly useful because it ignores outliers and gives a better sense of the central spread of the data. Variance. Variance measures the average squared deviation from the mean, providing a sense of how data values spread around the central value. For our data set, the mean is 20 milligram per liter. To calculate variance, we first find the squared deviations of each value from the mean. For 10, we minus 10 from 20 and take the whole square. It will result as 100. The same will be done for 15, 20, 25, and for 30. The total is 250, and dividing by the number of values, 5, gives us a variance of 50th. Variance is a bit abstract because it uses squared units, but it's the basis for the next measure, standard deviation. Standard deviation. The standard deviation is the square root of the variance, making it a more intuitive measure. It tells us, on average, how much the data values deviate from the mean. With a variance of 50, the standard deviation is square root of 50, which is approximately 7 milligram per liter. This means that the concentrations, on average, deviate by 7 milligram per liter from the mean of 20 milligram per liter. Standard deviation is widely used in chemistry because it's easy to interpret and provides a clear understanding of variability. Practical significance in chemistry. Each of these measures has practical applications in chemistry. The range gives a quick sense of the total variability. The interquartile range focuses on the central portion of the data, avoiding the influence of outliers. Variance quantifies variability using squared deviations, making it useful for theoretical calculations. Standard deviation is intuitive and widely used for comparing data sets. Together, these measures help ensure consistency, identify anomalies, and improve reliability in experimental results, which is crucial in chemistry.